Okay, so the second part to Karnaugh Maps is how do you take an expression, a logical Boolean expression like this, C and B or D, how do you turn that into a Karnaugh map? Because this is something you could also get asked in exam. And once I've showed you this example, I'll maybe do another example and show you the past paper questions so you have an idea of what you need to answer. So basically, we're going to have two boxes, because if you remember the rules of Karnaugh Maps, you look at the article, which is in the link below here. When you combine expressions within groups using and then combine between groups using or. So C and B will be one box. So where is C and B true here on this graph, on this table? Sorry, it's a grid. Obviously, when you have like four inputs like this, you have to put all the different combinations of the different inputs. So if you've got A and B along here and C and D down here. And so this first one, 0, is for C. Second one here, 1 is for D. So C and B both being true. Well, where is C true? C is true here, but B is not true here. But C is true here and B is true here. C is true here and B is true here. C is true here, B is true here, and here as well. And then that's basically the only possible places you can put a 1 for C and B. Because where basically C is not true on these lines, although B is true here and here, but it's not true there, so we can't put a 1 there. And so now we have to find D. So where is D true? Well, D is true on this line. We can put a 1 here, a 1 here, a 1 here, a 1 here. And then D is true here. It's got a 1 here and a 1 here. And then everywhere else, you just put zeros, because this is where that Boolean expression is not true. And just to prove that this is that expression, we could now do our box rule thing. So you want to choose the biggest boxes. It's got to have 1, 2, 4, or 8 in. Why the biggest boxes? Because it simplifies the term the best. So the biggest boxes are this one. Has 8 things in it, and then we could choose. We could do this one here. So it's got 4 things in it. It overlaps there. It needs to overlap, because then you can say C and B or D. So if we look at my example, so if you go to practice 2, this is where you can find some of the tests. So filling in Karnaugh map. This is C and B or D. So we've filled in all the boxes, and then we can draw these 2 big boxes here. So this big box here is D, and this small box here is C and B. So if you go to practice 2, you can then have a go at some of these other examples. Maybe I'll just do one more with you. A and C, not A and C. So if we were going to choose not A and C, well, we need to find where that is true. Not A is true here and here, so it'll be on this column. But where is C true? It's true here and here. So you put a 1 here, a 1 here, a 1 here, and 1 here. So you just have that box, and that'll be not A and C, and everywhere else would be zeros. So have a go at finishing these other ones to practice putting a Boolean expression into a Karnaugh map. And then go and check your answers. You can look at them at the end. And then once you've done all of that, to practice both things you need to know about Karnaugh maps, either evaluating what the Boolean expression is from the Karnaugh map, or getting or putting the Boolean expression into the Karnaugh map, you can have a look at what some of the things you'll be asked to do in the exam papers. And there'll also be model answers here as well. So, for example, when they ask you about Boolean algebraic expressions, they often give you something like this: Q equals not A or B, and they'd want you to draw what the logic circuit gate would look like for that. But logic gates is another video, although not that complicated at all. And then to find a Boolean expression, so this is what we've been doing before. What would this Boolean expression represent? So you've got to figure out, draw your boxes with those rules. It's got to have 1, 2, 4, 8, 16. And it's got to be either like a square or rectangle shape. It cannot be diagonal. So draw your boxes and then draw the terms. And then here, in the 2020 paper, so they do ask you to do it the other way around as well. I'll zoom in on that. It says complete the Karnaugh map below for the Boolean expression not A and not B, or A and not B. So you'd have to put a 1 where you'd find that, and you have to put a 1 where you'd find that, and you end up with 2 boxes. And then they're asking you, how can you simplify this using your Karnaugh map? So, for example, in this example up here, when we well, this one couldn't be simplified anymore, really. It's D or C and B. There's no way you can actually simplify that. But in this question here, that they're suggesting that this Boolean expression here could be simplified more. So how would you do that? And then there's another bit on D-type flip-flop circuits, which is another topic entirely. And then again here, they're asking you to put this Boolean expression into this box and simplify it. And then they're asking you to draw a logic diagram for that expression. Okay, so yeah, this completes the videos. So I've showed you, discussed what a Karnaugh map is, how it's used, how we can use it to simplify circuits. The two-dimensional one, you know, they're two-dimensional truth tables basically, where you've got several inputs, A and B, or you can have more than 2. You can have 3. You can have 4 inputs, like here, C and D. You have to follow certain rules. There has to be 1, 2, 4, 8, 16 powers of 2, and they have to be square or rectangle shaped boxes, and they cannot be diagonal. And that's all you really need to know. And the best way you can understand this is by doing the practice questions and then looking at the model answers to check you got them.